Do not know what I just pushed. Oh, okay. Anyways. So for this one, our b is what? Yes, this is what's being raised to a power. And is it greater than 1? So it's growth. It's exponential growth. Alright, this one is what? Decay, because the 1/4 is what the exponent has, and it's in between 0 and 1. So this will be exponential decay. What about the next one? Growth, because what's the number we're looking at? Just 3, right? 3 is the only one with the exponent. And so this will be growth because 3 is bigger than 1. And now for these problems, all we're going to do is graph it using a table. So we're coming up with a table. And then we're going to find the domain range. Alright, so I'm going to make my table over here. For your test, I want 5 values for x. You get to make them up, but I want some of them to be negative, some of them to be positive. So I'm going to start with -3, -2, -1, 0, and 1. And those are the 5 that I'm going to use. Again, I just came up with those, just some of them have to be negative and positive. And how do we find our y value? Good. Plug 3 in, or -3 in, for the x in the original. So go ahead and type in 2 to the -3rd power in your calculator and tell me what you got. 0.1 what? 25. Okay. Alright. Yeah, round to the nearest 100 on most of these, so you could put 0.13 right here if you wanted to. I'm just going to leave mine like that. I'll tell you on the test what I want you to do. Alright, what about -1? 0?
1.
And 1. Good. And if you have trouble typing those in your calculator, now would be the time to ask, not on Friday for the test. Anybody have problems plugging this in? Okay. Just 2 raised to instead of x used to -32. When you plug them in, don't plug it into the y equals sign. Just do it on -3.
As equals to the y equals button on here, and it did it automatically.
Yeah, we're going to talk about that in a second. Alright, so let's go ahead and graph it. So -3, first of all, I know this might sound silly, but some people have questions. What is this value in between? 0.125. 0 and 1, right? And is it closer to 0 or closer to 1? Good. Okay. So -3, just a little bit above 0. -2, a little bit more above 0. -1, halfway between 0 and 1. 0, 1, 1, 2. Alright, and exponential functions, you can tell by these two examples, which I'm going to scroll up for a second, that they go on forever, both sides, right? There's arrows on both sides. So this is how our graph will go. It's going closer and closer to what on this side? 0. So I'm going to draw it closer and closer to 0. On this side, it's going to keep increasing forever, correct? Okay. Now let's do our domain and range. And by the way, you can see this is growth because the graph is increasing as it goes on. Alright, so domain and range. Domain is talking about your what values? X. So like from left to right, correct, on the graph? So how far left is this graph going? Yeah, negative infinity. All the way left forever and ever, right? What about how far right is it going? Yes, because the further up it goes, the further what? Right it's going to go. So it's going on forever and ever. So instead of having all these infinity signs, what could we write for domain? All real. All reals. All real numbers. Do you think that it'll be like that for every exponential function? Remember I said on these two how it's going to go on forever to the left, forever to the right. Same thing here. They don't end on either side, so do you think it'll be all reals for each one? Yes. Alright, but the range is dealing with y values, so up and down, right? So this looks like it'll go up forever, correct? But is it going down forever? It's kind of just going out to the side, right? But the closer, or the smaller we get on this side, the further left we get, the closer y gets to what? 0. So all the y values here are not touching 0. They're not less than 0. They are what? Greater than 0. Right? And do you think it'll ever touch 0? No. Nope. It'll just keep getting closer and closer and closer and closer and closer. Maybe it finally will. We don't know. So for f of x, we're going to have to say that all these values are what? Greater than 0. Good. Couldn't put equal to because we don't know. Any questions about that one? Now I'll show you a shortcut if you have a graphing calculator. So if you will, go ahead and type this into your y equals button, 2 to the x. And go ahead and type it in. And then hit second graph. Once you do that. And is everybody there? Yes? Alright, you see the table? If you have a graphing calculator, you don't have to calculate these by hand. Do I still want you to make a table? Yes, but for example, for -3, it already tells you this value beside it, so you don't have to calculate them. So I need 5 values, then you can graph it. And if you hit just graph now, just graph, it'll show you what it looks like, and yours should look very similar. So if you have a graphing calculator, you don't have to calculate these by hand. Any questions? Okay, let's do the next one then. So our x and y values, y'all give me some x and y values. Y'all want to use the same ones? Yes? Okay. -3, -2, -1, 0, 1. I'll give you time to go ahead and type that in your graph calculator. Those of you who don't, go ahead and figure it out on your own. And then I'll call on people for the values. Yeah, you can go ahead. You don't have to wait. Right now. Do you put 1/4? Yeah. So y equals 1 raised to the x, and then second.
And then I just hit I hit graph. I didn't put the x, I tried to fill it in.
Yeah, how do we go back to the original? 2 to the x, it's got to be raised to x. Just like, see how we cut that one? Now the second graph. There's your second. And see how we do the same values? You don't have to calculate it? Yes. Alright, let's go over this one.
64.
Yeah, you can't graph that one. We're about to go over it. Alright, so Grant, what'd you get for -3, the value?
64.
Alright, Julie, what'd you get for -2?
I didn't get it. I have my calculator in my car.
Okay, well, y'all know I have calculators up here. Anybody that needs a calculator, come get one. You can't make it through this class without one. No point in just sitting there and waiting for the answers and then you can't figure it out on your own. Jackie, what'd you get for -2? Isabel, -1.
4.
Miguel, 0.
1.
Alright, Antonio, 1/4. Or excuse me, plugging in 1.
0.25.
Good. Alright, any questions about those values or how we get them? Okay, so obviously we can't graph 64 on here, correct? So I'm gonna mark that out. We can't graph 16 either, so I'm gonna mark that one out. So I really need 2 more values. So what do we get for 2?
10625.
Hold on. Okay. The reason I added 2 more values because we can't graph 64 or 16 on this graph. All right, and what did y'all get for 3?
0.0156.
156. Okay. So I'm gonna go ahead and graph them. So -1/4 is gonna be right here. 0, 1. 1.25, so a little bit above 0. This one's very close to 0. Again, very close to 0. Okay, so we can tell this is decay because, again, it's decreasing as the graph goes on. What do you think the domain would be? All real, same thing. All right, for the range, what do you think? Good. Again, there's no values less than 0, and as we get bigger, as our x values get bigger, it's approaching 0. So it would be f of x is greater than 0. Do you think it would be like that for all exponential functions? No? Okay. Just saying. Any questions about that one? Okay. Same thing, you're going to do this one on your own. Let's all pick the same x values, though. Or we don't have to. You can pick your own. So pick your own x values, find your y values, and graph it. And then we'll talk about domain and range together.
I know this word is downstairs.
Yeah.
Okay.
-3 plus 2 is what?
Huh?
3 raised to -0. And then subtract. Sometimes it's easier just to
When you
reduce
raise
it.
them to the you see how your calculator can mistake this for 3 to the x plus 2, like it looks like you're going to the x plus 2 and minus 2. That's what the calculator takes you to. Then you do 3 and then less. Yes. X plus 2. Let's try that again. Yes, this one. No, you can't graph this one, right?
So you'll need another value. So negative 4.
Oh,
You get what I'm saying?
yeah.
Like you can't graph.
So if you can't grab the higher, yeah,
Yeah, you'll need 5 of them. But this is
negative 1.6666. Or 667.
Yes. Range isn't right, but we'll go over it.
The opposite way.
Yeah, it's always going to be greater, because notice how these values are going up, and it won't be 0. You see how there's the zero, y values past 0?
Oh, so
We'll go over it. Alright, anybody need more time just finding the values? Alright.
Oh, there's a question. How do we, I know you already know this,
Yeah, do you remember how we remember it? The number that has the exponential. 3 is greater than 1. Okay, let's go over these together. So, we had to use negative 4, negative 3, negative 2, negative 1, 0. Because what did we get when we plug 1 in? Okay, we can't graph that one. That's why I picked negative 4. Alright, let me finish zooming in. Alright, Megan, what'd you get when you plugged in negative 4?
Negative 1.88.
Alright, Chris, what'd you get for negative 3?
1.66.
Is it? Okay.
Sorry.
Darian, what'd you get for negative 2? Mackenzie, what'd you get for negative 1?
Get that far.
Alright, you could just plug it in right here. Negative 1 plus 2? 3 minus 1, or 3 minus 2.
1.
So we'll do it again. Negative 1 plus 2 is 1. 3 to the first is 3. Minus 2 would be just 1. Jackie, what'd you get for 0? Okay. Any questions about those values? Okay, let's go ahead and graph them. So negative 4, negative 1.8, that's close to negative 2. Oops, I'm definitely not at negative 4. Sorry about that. Alright, negative 3, negative 1.67, negative 2, negative 1, negative 1, 1, 0, 7. Okay. So for the domain, it would be what? All reals. Alright, what do you think the range would be? Any guesses? Alright, what about negative 2, Will?
Greater than negative 2, that should never be.
Good. If you look at your, let me borrow your calculator, Miguel. If you look at your table, if you have a graphing calculator, let me show you. Notice how, oh, there we go. The smaller you get, the closer to what it gets. Not just 2. Negative 2. It's approaching negative 2. And you can also see that from the graph, that it's approaching that y value of negative 2. So just like this one was approaching 0, this time it's approaching negative 2. So f of x, all of these values have to be what? Yeah, do you see any less than negative 2? Anybody? Anybody see any values less than negative 2? No, they're all greater. So this has to be what? Here you go. Alright, and let's go back and look at all the originals and then look back at domain and range and see if we see anything. That kind of looks like 21. Alright, looking back at all the original problems, and I'm going to box them in. 2 to the x, 1/4 to the x, 3 to the x plus 2 minus 2. What's different about these? Anybody see any differences? You literally cannot have a wrong answer, guys. I just want you to name some differences about the problems. Okay, this one has a negative 2 on the end, right? That one's a fraction.
The fractions go in all two directions, all numbers.
Good, because it's decay. Alright, so those are good differences pointed out. Now let's look at domain and range. Notice how these two are the same. They have the same domain, same range. This one has a different one. And it's negative 2. And what did y'all say about this one? There's a negative 2 on the end. And that's where the range is. So, an easy way to tell what the range is, instead of just looking at the graph, if something is added or subtracted, now not multiplied, if it's added or subtracted to the exponential function, then that's what the range is going to be, greater than negative 2. Is there anything added or subtracted right here? So it would be greater than 0. Same thing here. So for this example, this is not in your notes, and you don't have to copy this down, just say it out loud. What would be the domain of this function? Domain. All reals. Range? Greater than 0. Why? There's nothing being added or subtracted. This one, range.
Greater than 0.
Greater than 0. This one, range.
Greater than 2.
Good. This one, range.
Greater than negative 2.
Good. That's the easy way to identify range. You don't even have to graph it. You already know what it's going to be. Any questions about that? Okay, this worksheet is what I'm about to pass out to you guys, and it's really supposed to be worked with a partner, but if you don't want to work with a partner like Will, you could just compare your graphs to them. Julie, you could compare your graphs with them. I want you to each graph number 1, then show each other your graph, make sure it's the same, make sure your domain and range are the same. If you can't agree on anything, just raise your hand and I'll come help. Go ahead. You can compare your graphs to somebody.
I'm tired. Why? This is fun.
It's not fun, actually.
It is. It's so much fun.
No, it's not.
It's so
Yeah. No.
Alright, tomorrow when y'all come in, y'all are going to be back in assigned seats. If we can't do our work, if we can't stay off our phone during notes, assigned seats tomorrow. And for the rest of the year. What now? Yes, but if you have a calculator, like I said, you don't have to work it out. And I'll need 5 values. Around this one. I don't think it'll make a difference though. Yeah, round the values to the nearest 100. Yeah, they're the same graph. Once you have done all of these, I will check for correctness. If it's correct, you can pack up.